Hi, this is Mrs. Griffin with Unit 1, Lesson 6. We're going to talk about triangles and some of their properties. You're going to do opening exercise on your own. Your goal today is to be able to classify triangles in two ways and to find the measures of some of the angles. So we have 6 types of triangles that we're going to discuss. Each triangle that we ever look at can be classified in two ways, one by angles and one by sides. By angles, we have all acute angles, which means every single angle in this triangle is less than 90 degrees. A right triangle, which will have one right angle, and the other two will be acute, less than 90. And then we have an obtuse triangle, which has one obtuse angle, which is between 90 and 180, and then two acute. By sides, you can actually figure these out by sides classifications using angles or their side lengths. So in an equilateral triangle, all 3 sides would be congruent and all 3 angles would also then have to be congruent, which would mean that every single angle in an equilateral triangle, which is also known as an equiangular triangle, would be 60 degrees. An isosceles triangle has 2 congruent angles. Those are called the base angles. They're called that because they're the same, and they are both connected by the base of an isosceles triangle, which is the different side, and then it has 2 congruent sides, which are known as the legs. The third angle, which is the different one, is called the vertex angle. So when we're discussing isosceles triangles, the base is the different side, and it's across from the vertex angle, which is the different angle, and the base angles are the congruent ones, and they are across from the congruent sides. And then we have scalene, which is going to have 3 different angles and 3 different sides. So you'll have 3 completely different angle measures across from 3 completely different side lengths. Okay. Few things. The angles of a triangle always have a sum of 180 degrees, so if you add up the angles, they'll always add up to equal 180. And the angle-side relationship, which says that in any triangle, across from the largest angle is the longest side, and across from the smallest angle is the smallest or shortest side. And therefore across from the medium angle is the medium side. Okay, when we say across from, 2 sides always make an angle. Across from the angle is the one that's not meeting it at that corner. And then finally the triangle inequality theorem, which says that if you have any triangle and you know the lengths of 2 sides, the third side has to be between the difference. So here's your first angle minus your second angle. And that would be the difference, and it's going to be a number. Your third angle between that difference and the sum of the other 2. Okay, and because of that, any 2 sides that you pick, when you add them together, they always have to be greater than the third side, not equal. Okay. So we're going to use some of these ideas in our examples. So we have a triangle. It says the measures of 2 angles of a triangle are 70 and 55, and we want to find the classification, which means we need to know what that third angle is. So we can add them together and then subtract from 180, because the sum of the angles has to be 180, and we will get that this is also 55. Okay, so because we have 2 that are the same, this is isosceles. And because all 3 are less than 90, it is acute. So 2 congruent and all less than 90. Okay, same idea here. If 2 angles of a triangle each measure 20 degrees, then we need to know what the third one is. So we add those together, you're going to get 40. And when you subtract that, you'll find out that the third angle is 140. So just like the other one, because we have 2 that are congruent, it is isosceles. And because one of them is larger than 90, it is obtuse. Okay, number 3. We have the 3 angles of a triangle in expressions this time, and we need to be able to classify. So just like the others, we know that the sum of all three angles has to be 180, so if you add them together and solve, you're going to combine your like terms and get 10x plus 20 equals 180. Subtract your 20 from both sides, and then divide by 10, and then substitute back in. You're going to have 16. 3 times 16 plus 20 would be 68, and then 6 times 16 would be 96. So these are your three angle measures. And because we have one that's bigger than 90, it's obtuse. And because all three are different, it is scalene. Okay, continuing on. For number 4, same idea, we have our three angle measures, so adding those together you'll get 12x equals 180, and when you divide by 12 you'll get 15, and then substitute back in. 2 times 15 is 30, 4 times 15 is 60, and 6 times 15 is 90. Because we have a 90-degree angle, it's a right triangle, and because all three are different, it is scalene. Same idea here, we're going to add them up. So we're going to add them. I'm going to put those together and get 15x plus 30, and they would add up to equal 180 because that's what a triangle does. And we're going to solve. Subtract 30 from both sides, divide by 15, and you get 10. And then you're just going to substitute back in. So 10 plus 30 is 40. 4 times 10 plus 30 is 70. And 10 times 10 minus 30 is 70. So we have two congruent ones. That makes it isosceles. And all are less than 90, so it is acute. Okay, now here's an isosceles triangle. So when I draw it, I'm going to draw it and mark immediately off two sides congruent. And if you imagine that these are arrows pointing across the triangle, those two angles are congruent as well. Remember, those are the base angles, and this is the vertex up here. Alright, and we are trying to find the vertex if one of the base angles measures 24 degrees. Remember that base angles are congruent in an isosceles triangle. So we would add them together and subtract from 180. And 180 minus 48 would be 132 degrees for your base or for your vertex angle. Number 7, find the measure of each angle if they're in a ratio of 3 to 5 to 7. Remember that a ratio basically means throw x on each of those numbers and do with them what makes sense for the problem. So those are three angles of a triangle, and we know that those three angles would add up to 180. So we have 15x equals 180, and when you divide by 15, you get 12. Okay, and then we're going to substitute back in for each one and figure out the angle measures so that we can classify it. So we have 36, 60, and 84. So all are less than 90, that makes it acute. And they're all different, which makes it scalene. Or another isosceles triangle, so again you're drawing with two congruent sides. It doesn't matter which ones, just across from those are going to be your congruent angles, your base angles. So the vertex angle is 4 times as large as each base. We don't know what the base angles are. We actually know less about them than anything else, other than that they're the same, so I'll make them both x. If the vertex is 4 times that, we would write 4x. And just like all the others, we're going to add them up and equal to 180. So 6x equals 180, and when you divide by 6, you're going to get 30. And then you can realize when you substitute back in that the two base angles will each be 30, and 4 times 30 is 120. And that is our answer. Okay, number 9. The angles of a triangle are represented here, and it says explain why it's obtuse. So what we need to do is justify it with work. So we have to actually show why that's going to happen. So x, 2x, and 3x make 6x. Negative 12, 8, and 4 add up to 0. And those would add to equal 180, because that's what a triangle does. And we're going to divide and we're going to get 30 for x. And then substitute back in. 30 minus 12 is 18. 60 plus 8 is 68. And 90 plus 4 is 94. So it's obtuse because one angle is greater than 90 degrees. Alright, number 10. So we're still dealing with the idea that a triangle adds to 180, but now our question is a little different. So we have a triangle ABC. It really doesn't matter how you label the corners. This is just for reference. C is going to be 118 degrees, even though my picture doesn't look it. B would be 44. And in order to know which side's the shortest, we need to know what the third angle is. So just like the others, we're going to add the two that we know about, and then subtract from 180. And get 18 degrees for our third side. So the shortest side is across from the smallest angle, which would be the 18. So across from the 18 is side BC, and that is your shortest side. Same idea on the next one. We have RST. R would be 75, S is 20. Those add to 95. And that would mean that the third angle would be 85. And so the question is, what's the longest side? So the longest side has to be across from the largest angle. So the largest angles are 85. Across from that would be side RS. On number 12, very similar question. We have a triangle ABC. A is 55, B is 25. Add those together, and that is 80. Which means the third angle is going to be 100. The longest side is across from the largest angle, and so that would be side AB. Okay, and now the final concept. If two sides of a triangle have a length 4 and 9, the length of the third side, remember, it's between the difference and the sum, but it cannot equal either. So it must be a number between 5 and 13, but not equal. So that would be greater than 5, but less than 13. Same concept here. We're going between the difference and the sum. It has to be between 3 and 5, but can't equal either. So that would be 4. Concept here, same idea. 3 minus 2. And 3 plus 2, we have to be between 1 and 5, but can't be equal to either. And this one wants to know what one will not work. So you can't equal 1 or anything less than that, and you can't equal 5 or anything more. So 1 is not going to work here. Okay, and continuing that idea, which set of integers cannot represent the lengths of a side of a triangle? Remember that two sides have to add up to be bigger than the third. The easiest way to check that is to look at the smaller 2. If you add 4 and 7, that's 11, which is bigger than 9. So this is a triangle. We want one that's not. If you look at 4 and 8, that equals 12, and that's not bigger than 12, so this cannot be a triangle. Okay, 12 is bigger than 11, and 19 is bigger than 11. Which one of the following steps could represent the lengths of the sides of an isosceles triangle? So immediately I can eliminate some choices, because isosceles triangles have to have two congruent sides. So this one doesn't have two the same, and this one doesn't have two the same. And then I can confirm the rest of it using the same idea, that when I add the smaller 2, do they add up to be bigger than the third one? And in this one they don't. So this one is the one that could represent the sides of an isosceles triangle. For number 18, same idea. We're going to say which one of the following sets of numbers cannot represent the sides of a triangle. So go to your smaller 2 and add them together. If it's bigger than a third, it is a triangle. 5 and 6 is 11, which is bigger than 7. 7 and 11 is 18, which is not bigger than 18, it's equal to it. And then 6 and 8 is 14, which is bigger than 11. So C cannot be the sides of a triangle. Alright, and then finally for 19, it has to be an isosceles triangle. So if one of the sides is 10 and the other is 5, it's either going to be another side that's 5 or another side that's 10. And it's got to be between the difference and the sum, but not equal to either. So it can't be 5, which means it has to be 10. And then the smallest angle would be across from the smallest side. Okay, I will see you in class.